For bat and dolphin species, it is extremely important to be able to locate prey for growth, nutrient intake, and ultimately for their survival. More often than not, successful detection and location of prey is reliant upon specialized physiological mechanisms found within each organism. For most bats and dolphins, this mechanism is referred to as echolocation, a tool used for awareness of surroundings and especially for efficient hunting in dark places. The technique used for prey detection is shared between both taxonomic groups, yet there is notable differences between the mechanisms used to produce such sound. This forms the fundamental question of how and why do the physiological mechanisms differ between both groups. In most cases, many of these physiological differences are due to the differences between their living mediums of air and water. In simple terms, echolocation is a device used by, but not limited to, bats and dolphins that produces sounds of high frequency to allow an organism to understand its own as well as prey locality in darkness by the rebound and interpretation of sound. The physiological features used in the production of high-frequency sound for echolocation varies greatly between bats and dolphins, with even slight differences amongst bat species themselves. For bats specifically, there are two distinct methods used for the production of echolocation sound. One method used by the majority of bat species is to produce sound through their larynx by the striking of the sternocleidomastoid bone onto the tympanic bone. This sound will exit the organism either through the nose or mouth. The second, less frequently used method associated with more specifically the fruit-eating species is to produce sound through a series of high-intensity tongue clicks. When a sound wave rebounds off of prey, it is first received externally by the ears. The ears have a definitive structure-function relationship because efficiency of this hunting technique is achieved by ears with often a large surface area, capturing and directing sound waves into the bat to allow for interpretation of the current and future positioning of prey in its environment. Compared to bats, dolphins share one common method for echolocation, one which only varies slightly between each species. Firstly, a dolphin has to maneuver air through specific chambers in the skull region of its head, known as nasal sacs, before moving it through a region consisting of the phonic lips. The sound is then channeled through a fatty lipid-based substance located near to the dolphin's forehead, referred to as the melon, before exiting the dolphin. The return of sound is received by another fat-based region in the lower jaw and finally perceived by the dolphin's brain to identify prey locus and its movements, similarly to bats. Both the bat and dolphin species live in highly diverse mediums, and therefore, the way in which echolocation is used by both groups is heavily influenced by the properties of air and water. Due to barriers placed by the different properties, there are some minor differences and limitations between each method used for echolocation. Comparing the two mediums, sound is predicted to travel at a 5 times slower rate in air than through water. And secondly, is also absorbed much faster in an air medium as well. In relation to bats, this essentially means that the higher the frequency of any created sound in an air medium, the smaller the distance that such sound can travel, even though higher frequencies give a better representation of prey positioning in both mediums. Due to the two combined factors, a bat is known to only effectively identify prey within approximately 5 meters, whilst dolphins are specialists in echolocating prey up to just over 70 meters away. In each medium, both groups need to maximize their efficiency of hunting using ultrasonic sound, and due to all medium factors, the optimum frequency range for both species has been determined as similar, between 10 to 150 kHz, with major differences applying to the distance travelled by sound and its speed. Finally, awareness from the prey's perspective of echolocation sound is also a major factor contributing to the similar frequency range used by both groups.